technology or some high-end gadgets, but cleaner air is an important aspect of it. The major problem we will be facing on project is first of all monitoring the air data, and then storing that data, analyzing that data, and suggesting some good pollution control measures. The scope of this project will be that all major regions of emission of different air pollutants will be shown to the user, and the content of different pollutants at the present time will also be shown. And according to all that data, some good accurate air pollution control measures will be suggested to the user on a good interface. Main objectives we will be achieving are collection of data set of different pollutants of different areas, then storing that large data set into a central machine, then using some algorithms we will predict some values, and then take effective measures accordingly. Now, how we are going to actually achieve that? For data collection regarding pollutants, we are using air monitoring station, which we have developed by our own, and then achieving storage capability using cloud platform. The processing of data using different algorithms like machine learning to predict next day's AQI, and we show those AQIs on a good interface. As this is our basic diagram, there is a web interface, mobile application, processing unit. For processing unit we are using Raspberry Pi, and for air monitoring sensors we have used some sensor which will be explained later in detail. Our basic requirements can be categorized into three categories. First is Internet of Things, where we have used Raspberry Pi to actually connect to the internet and uploading that data. Then we have used big data algorithms or processing units to store that data, analyze that data, and showing some good results. For our cloud computing we have used Firebase, already told. Basic outcomes we will be getting first our online portal where general public can submit their complaints if their air pollution is really high, and automatic challan system if the vehicle's pollution checking date is due or it's very late. It also have future city planners to plan city accordingly where air pollution is really low. Then an automatic message alert system will send to the people regarding maintenance of their vehicle, and there is also prediction system that predict the future trend of air pollution. Here is a demo video. Here is our hardware. On the right we have Raspberry Pi connected to the power source. We have used ribbon cable to connect to the shield. On the shield's left we have three sensors. First is MQ135 telling us amount of ammonia and benzene in air, MQ2 telling us smoke and LPG in there, and MQ7 about carbon monoxide. Then on the top there is PM2.5 particulate matter pollution sensor. Here is our test drive. We will be testing this project by running some commands. First I will go into the specific directory where my Python scripts are stored. It is in home/pi. Now I will use Python to run our Python script. Here is Python space smoke .py. Wait for it to run. Yeah, our sensors need about 90 seconds to heat up to give us accurate measures of all the pollutants. It will be running. We have to just wait for a second. Here as we can see, after calibration, a reading of some data like LPG, carbon monoxide and smoke, etc. There is also ppm value there. All the data now will be uploaded to this Google Sheet right here. As you can see, all the parameters are here: temperature, humidity and different pollutants. And we have set the frequency of data reading about 10 seconds, and the basic chart of each pollutant on date and time is shown right here. We plan for our system to be installed throughout the city because it is better than those high-end products, because they use really expensive sensors. Our system, our one single system just costs about 10,000, and they can be installed all over the city. Because of it is a distributed network. Even if one node goes down, other is still up and running, giving you all the important data. So this is our project. Thank you.